So example 5.2.2, using the binomial command on the TI-84. So when looking at a person's eye color, it turns out that 1% of people in the world have green eyes. So consider a group of 20 people. So explain why this is a binomial experiment. So first off here, each person is a trial. So it's like each individual that we had earlier, so each person is a trial here. And there are 20 people. So n equals 20. Okay, so n is a fixed number here. Number two is that we have to have independent trials. So again, in this case, we're going to assume that the eye color of one randomly chosen person does not affect the eye color of another randomly chosen person. And this, again, is where randomly chosen is important, because again, if you just grabbed like 20 people that you're all related to, then eye color is something that is inherited. And so again, there is going to be a dependency in eye color for people who are related. But if we just randomly choose 20 people, the eye color of one should not affect the eye color of another. So we can assume, so we have independent trials. All right, the third condition is that each of these trials has to have exactly two outcomes. So if a person is a trial, so one person, and either they have green eyes or they don't. So there's two outcomes to each trial. And then the fourth thing is that the probability of a success has to remain the same. So in this case, we're going to look at the probability that a person has green eyes. And that was given to us to be 0.01. So that is going to be our lowercase p for this case. Okay. All right, so this is a binomial experiment since all of the properties are met. Alright, so when we have a binomial experiment, our random variable is going to count the number of successes in n trials. So in this case, the success is having green eyes. So again, that doesn't mean green eyes are better than any other color. It just happens to be what they're interested in counting. So that's how we define success in the binomial experiment. It's just whatever category you're interested in counting. So this is the number of people with green eyes out of 20 randomly selected people. All right, so part C, we're asked to find the probability that none have green eyes. Okay, so if we translate that into a probability statement here, that means we are looking for the probability that our random variable x, which is counting the number of people with green eyes out of 20, if none of them have green eyes, we want the probability that the random variable x is exactly equal to 0. So since this probability has the event x equals 0, okay, so remember, probability functions, what's inside the parentheses here is called an event. Okay, so it's going back to some vocabulary from chapter 4. But since it has this equal sign in it, that means that we are going to use the binom PDF command on the TI-84. Okay, so on the TI-84, you would go to the distribution menu and select binom PDF, and then you would enter the values 20.0 and 0. Again, using the technology box on the previous page and which operating system you have. Okay, but no matter which operating system you have, the results that you get in the end look the same here. So in this case, we could round this to about 0.818. So the probability that x is exactly 0 is about 0.8179. Right, so what does that mean in the context of this problem? So that means there is about an 81.8% chance that in a group of 20 randomly selected people that none of them would have green eyes. Now again, if we take this statement here, probability that x equals 0 is approximately 0.8179, and if we translate all those symbols back into the wording of the problem, keeping in mind that x was counting the number of people with green eyes out of 20 randomly selected people, okay, this statement basically says the probability that the number of people with green eyes out of 20 randomly selected people is 0 is approximately 0.8179. Okay, but that kind of reads a little weird. Okay, it makes sense in what we said, but again, the sentence we've written is more how people would typically say that. Okay, so there's about an 81.8% chance in a group of 20 randomly selected people that none of them would have green eyes. Okay, so very highly probable that that would happen.